Today, we dissect why Pakistan faces a Pinaka problem. In the 21st century, the geometry of warfare in South Asia has changed more drastically than at any time since the 1971 India-Pakistan conflict. The pivots of this transformation are not aircraft carriers or ICBMs, but a product of indigenous innovation. India's Pinaka multi-barrel rocket launcher. Spotlight how Indian scientists far surpassed initial demands for accuracy, unbox the technical facts, and simulate the next war scenario where Pinaka operates at full capacity. Pinaka's inception originates from the lessons of the Gulf War and the recognized vulnerability of Indian forces to well-coordinated artillery barrages. During India's Kargil conflict, artillery, especially multi-barrel rocket launchers, proved crucial for dominating mountainous terrain. The Indian Army, seeking autonomy from Russian BM-21 Grad systems, tasked India's Defense Research and Development Organization to create a system with rapid deployability, saturation firepower, and a degree of flexibility unseen in imported models. With Indian defense industries like Tata Advanced Systems, Larsen and Toubro, and Ordnance Factories Board collaborating, Pinaka was born. The Pinaka Markai system features a 12-rocket, electrically fired cluster on an 8-wheel Tatra vehicle. A single salvo covers 1,000 square meters, deploying 960 kilograms of warhead in under a minute. Each full battery comprises 6 launchers, 6 load replenishment vehicles, 3 resupply trucks, and 2 command vehicles containing advanced fire control computers, enabling rapid repositioning and coordinated missions. Early batteries fired unguided rockets with a 37.5 km range and a circular error probable, or CEP, of roughly 100 meters. Indian engineers, however, were not content. The Markai enhanced reaches 45 km, and the Pinaka Markai I, using an inertial navigation system with satellite guidance, now reaches 75 to 80 kilometers with a CEP as low as 2-3 meters, currently the best accuracy achieved by any system of its class worldwide. How DRDO surprised everyone. The technical narrative of Pinaka's accuracy is one of scientific outperformance. The Indian Army only required a system with a CEP of 60 meters at maximum range, effective for area targets like assembly zones and airfields. Through design iterations, DRDO and ARDE delivered rockets that consistently hit within 3 meters of their targets at full range, using India's indigenous navigation with Indian Constellation, NavIC, satellite system, and a ring laser gyro INS, completely homegrown and shielded from outside interference. In recent ballistic trials, over 90% of rounds landed inside a 2-meter radius at a test range in Pokhran. No other comparable rocket artillery system, Chinese WS-1, American M270 MLRS, or even the Russian Smerch, routinely reports such precision at these ranges. Pinaka's arsenal is customized for every tactical scenario. High explosive fragmentation. Standard round, devastating for infantry concentrations, soft-skinned vehicles, or runways. Cluster munition. Dispenses up to 60 submunitions per rocket, saturating armor formations with anti-tank bomblets or airbursting fragmentation. Incendiary and thermobaric. Targets fuel, ammunition, or infrastructure with high blast effects. Mine laying. Instantly blocks advancing columns by scattering anti-tank mines 40 km away. Each rocket can carry 100-250 kg of payload, scalable for future variants. Fragmentation pattern and submunition shapes can be programmed before launch, making it adaptable for area denial, precision softening, or high-value decapitation strikes. Battlefield survivability is engineered into every Pinaka element. Each launcher, built on a high-mobility Tatra 8x8, can leave firing position within 90 seconds, relocating before enemy counterbattery fire arrives. Loader replenishment vehicles are armored and automated, slashing reload time to under 10 minutes. Digital command post vehicles link up with satellite comms, drones, and the Army's artillery command and control system, fusing recon, fire control, and logistics into a single net-centric web. Indian developers focused intensely on robust electronics, jam resistance, and the ability to operate dark, without emitting detectable electromagnetic signatures. Pinaka can operate at altitudes over 4,000 meters, as seen in Ladakh exercises, and through -20 degrees C winter to 55 degrees C desert heat. The Pinaka Markai covers targets within 545 kilometers. The Markai I extends to 80 kilometers. The extended range, variant, exceeds 90 kilometers, and the upcoming Markai I is scheduled for range validation at 120 kilometers. From launch areas in Punjab or Rajasthan, Pinaka batteries can reach into the heart of Pakistan-administered border provinces, striking Sialkot, Gujranwala, Multan, Bahawalpur, and critical air bases like PAF Sargodha, Mayanwali, and Chaklala. Any concentrations of Pakistan Army assets or supply nodes within 100 km of the border can be neutralized in under a minute, complicating Pakistani war plans and logistics. What sets Pinaka apart on the global stage is not just the range or payload, but complete vertical integration. From propellant mixing in ordnance factories to electronics by Burrid Electronics, launcher chassis by Tata Advanced Systems, and missile guidance by DRDO, every critical component is Indian. This confers not only strategic autonomy, but also the ability to adapt the weapon to India's unique geography, from Himalayan valleys to Thar deserts and the swampy Sundarbans. Another pioneering feature is the modular design, allowing for different rocket calibers, currently 114, with plans for 300 and beyond to be fired from the same launcher. Future blocks will integrate loitering munitions, anti-drone fusing, and weather-adaptive trajectory planning. Pinaka is not just fielded by dozens of artillery regiments in India, but is also eyed by Armenia, Indonesia, and several African countries. India has overtaken Russia as the supplier of multi-barrel rocket systems to Armenia. The Atmanirbhar Bharat, or Self-Reliant India, initiative has ensured the entire supply chain is domestic, shielded from geopolitics. With a typical production cycle, India can field a new Pinaka regiment in under 6 months. Pakistan's Fateh series and strategic implications. In response, Pakistan accelerated development of its Fateh and Fateh-2 missile systems, with claimed ranges of 140 to 400 kilometers and guidance technology from China and North Korea. While impressive on paper, a claimed 10-meter SEP for Fateh-2 with a heavier warhead, the reality is different. Pakistani production is heavily reliant on imported electronics from China, with multiple delays due to sanctions. Pakistan lacks the industrial ecosystem for industry upgrades, unlike Pinaka, which is constantly evolving. Moreover, the Pinaka's superiority in multi-regiment operations, digital networking, and simultaneous salvos gives India an unprecedented conventional escalation capability. On the battlefield, Pinaka is integrated into the Artillery Command and Control System, ACCS, for rapid response. Drones, ground reconnaissance vehicles, and SWAT-high weapon locating radars networked through the ACCS allow Indian commanders real-time battlefield views and precise target updates. Drone-integrated surveillance helps revisit and retarget even moving enemy artillery or armor formations. Pinaka can conduct ripple fire for area destruction or sequential fire for multiple targets, all from concealed positions, minimizing vulnerability. Scenario: Pinaka in all-out war with Pakistan. Day 1, Hour 0. Tensions on the border escalate. Intelligence detects Fateh-2 launchers moving to forward positions along the Ravi River in Punjab. Simultaneously, Indian UAVs identify Pakistani brigade assembly areas near Sialkot, ammunition depots west of Gujranwala, and mobile artillery formations. A Fateh-2 barrage streaks skyward, targeting Indian logistics hubs in Jammu. Simultaneously, Pinaka Markai I and batteries from concealed positions 40 km behind forward defenses receive fire missions through the ACCS. Within minutes, salvos rain upon not just the Fateh-2 launch zone, tracked by SWAT-high radars, but also command posts, runways at Sialkot Air Base, logistic columns, and even rapid reaction mechanized units as they emerge from shelters. Pakistani digital comms go down as command bunkers are destroyed with pinpoint-guided rounds. Within the first hour, over 350 Pinaka rockets hit targets across 11 locations. Satellite imagery shows immense craters at Pakistan's forward arsenals and multiple burning columns as Indian infantry regiments surge forward. A single Pinaka salvo has constricted the enemy's ability to resupply, delayed reinforcements, and neutralized offensive assets, winning the counter-battery duel before close combat even starts. Countermeasures and escalation dominance. Pakistani air defenses, optimized for defending large slow missiles, struggle to track, let alone shoot down, salvo-fired Pinaka rockets arriving at multiple trajectories and speeds. Interception rates remain below 10%. Survivability further increases as Pinaka batteries relocate after every salvo, avoiding counterstrike via electronic direction finders or UAVs. Should Pakistan escalate with longer-range missiles, India has the flexibility to supplement Pinaka's R-Rage with Prale, ballistic missile, and BrahMos cruise missile, strikes integrated by ACCS into a larger kill web. Pinaka operates below the nuclear use threshold, providing Indian planners the doctrine of escalation dominance, where conventional superiority keeps threats contained without immediate risk of strategic retaliation. Indian maintenance and training cycles ensure Pinaka units remain operationally available over 95% of time. Modular components allow battlefield repairs. Pinaka ammunition is stored in hardened bunkers built for rapid distribution. Logistics units rehearse rocket highway drills, resupplying batteries with new rockets every 40 minutes in combat. Globally, only the U.S. high-mobility artillery rocket system matches Pinaka in rapid deployment, but HIMARS is not widely exported. Russian Smerch has longer range but inferior accuracy and maintenance in tropical climates. Chinese WS-2 systems imported by Pakistan face issues in high-heat, high-altitude Ladakh sectors. NATO nations have taken notice of Indian advances. Several have attended Indian Army Pinaka field trials as observers. Pinaka gives India a conventional deterrence option short of nuclear weapons. It enables quasi-strategic strikes on logistics, air bases, and field HQs, complicating enemy war plans with the knowledge that no target within 100 km is safe. Pinaka's non-nuclear posture also helps avoid premature escalation, matching firepower to mission objectives. Block 4 Pinaka rocket launchers will use artificial intelligence for firing solutions, coordinate with swarm drones for live targeting, and execute cross-domain strikes. Experiments are underway to equip Pinaka with anti-drone payloads and to integrate with mobile battlefield robots for resupply under fire. From its origins in DRDO laboratories to dominating the modern Indo-Pak battlefield, Pinaka embodies Indian self-reliance and innovation. For Pakistan, the Pinaka problem is not just about firepower. It is about the loss of initiative, the inability to safely mass forces, the certainty that any move will be met with an overwhelming, precise response. The legacy of Pinaka is clear: range, accuracy, speed, and indigenous development, shifting strategic stability in South Asia in India's favor, one rocket at a time.